Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet with me, Richard here. Yes, today we are looking at this question. It says that the molecular shape of covalent molecules determines several properties of covalent compounds, such as reactions, interactions, boiling points, melting points, and others. The shape or geometry of a molecule is predicted by this VSEPR theory. Okay? Then the question comes, says, write VSEPR theory in full. Okay, what does this stand for? Okay, it stands for valence shell electron pair repulsion theory. Yeah. Then we come to this question. It says, state whether the following is true or false. Okay, 1. According to valence shell electron pair repulsion theory, electron pairs in a molecule will arrange themselves around the central atoms of the molecule so that repulsion between their negative charge is as small as possible. Yes. Is it true or false? Okay, the answer is true. Yes. The arrangement of the bonding pairs is in such a way as to minimize the repulsive forces. So it is true. Yeah. Then comes this one. It says that the order of forces of repulsion is, okay, lone pair greater than lone pair bonding pair, which is greater than bonding pair. Is it true? Yes, it is true. The repulsive forces between lone pair and lone pair is the strongest, followed by lone pair bonding pair, then it is bonding pair. Yeah. Then we come to this question. It says, the geometry or shape of the molecule depends on the number of lone pairs or bonding pairs. Is it true or false? It is true. Yes. So we come to this question. It says, the geometry or shape of a molecule is mostly determined by the number of lone pairs and bonding pairs around the central atom. Okay? And the question says, define bonding pair. Okay, what is a bonding pair? A bonding pair is a pair of shared electrons between two atoms in a covalent bond. Yeah. Then we come to this one, a lone pair. What is a lone pair of electrons? The pair of electrons in the valence shell of an atom which is not shared with any other atom. Yeah, then comes this question. It says that for each of the molecule below, write the number of 1 bonding pair of electrons and 2 lone pair of electrons. Okay, how do you go about that? Okay, let us start with NH3, which is ammonia. Okay, when you look at ammonia, you realize that the central atom is nitrogen. So nitrogen is our central atom. So what do? You look at the group to which nitrogen belongs to. It's group 5. So what do you get from that information? It means that nitrogen has 5 valence electrons. So what do? We represent them. You say 1, 2, 3, 4. Then you start pairing 5. Yes. So from what we see here, we have already identified 1 lone pair. And this is it. Any paired electron here is what we call lone pair. So the 3 which are unpaired, they form what we call bonding pair. What happens actually, if you look at our hydrogen, you are going to realize that hydrogen has 1 electron. And what happens is that it uses that 1 electron to bond with nitrogen. So let us represent that 1 electron as X. So it comes here, and that is it. The same applies here. And the same applies here. Okay? So when you come to answering, what are we going to say? We are going to first say, what do we start with? 1. We start with a bonding pair. They are going to be 1, 2, 3. So, which means that nitrogen has 3 bonding pairs. Okay? Then 2 lone pairs. How many? We have 1. So, ammonia has how many? 1 lone pair. Now, next one is water, H2O. So when you analyze water, what do you note? The central atom is oxygen. So we have our oxygen atom, okay? And what do we say? We look for the group to which oxygen belongs to. It's group 6 or 16. That implies that oxygen has 6 valence electrons, which we represent as 1, 2, 3, 4, 5, 6. Now, I want to tell you that whatever is paired here is what we call lone pairs. So this is our lone pair, and this is our lone pair. Okay. So what happens to the unpaired electrons? You have to know that it is hydrogen which is going to bond. And what do we know about hydrogen? It has 1 electron. So it has 1 valence electron. So what happens? It brings that 1 valence electron here, and it bonds. Another one also comes here, and it bonds. Okay. Then we come to answering the questions. What do we say? You look at number 1. It says bonding pair of electrons. How many are they? They are 1 and 2. So there are 2 bonding pairs. Okay. Then number 2, what is it looking for? Lone pairs. And how many are they? They are also 2. So we have 2 lone pairs. Then lastly, we come to carbon dioxide. So when you look at carbon dioxide, you realize that it is carbon, which is our central atom. So the question is, carbon belongs to which group? It belongs to group 4. That implies that carbon has how many valence electrons? 4. So how do you represent them? It's going to be 1, 2, 3, 4. And we realize that we don't have any pair. So there's no pairing around. All these ones are unpaired. So which means that we don't have a lone pair here. Now we come to the way carbon bond in carbon dioxide. We need to know that it's going to bond with oxygen. Okay. And when you analyze oxygen, oxygen is group 6, implying that it has 6 valence electrons, which represent as 1, 2, 3, 4, 5, 6. So oxygen has 2 unpaired electrons. So it is the unpaired electrons which bond. So we are going to have a scenario where we have our central atom, okay, and these 2 electrons which are unpaired come here, and these ones come here. Those are the 4. That orientation causes the oxygen to come with its unpaired so that it can pair up, and we'll have a molecule this side like that. We come to this one. What is it? This side. Then we come to this side. Oxygen comes. Okay. And it brings its 2 unpaired electrons here. And we need to know that it also has 2 lone pairs. Okay. So this is what we are having. Then the question comes saying, how many bonding pairs of electrons? We have 1, 2, 3, 4. So there are 4 bonding pairs. Okay. Then another question comes, how many lone pairs? Okay. The answer is 0. So we have 0 lone pairs. Yeah. So that is that. So those are the number of lone pairs and bonding pairs on the central atom of each molecule. And with that, I would like to say thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. We urge you to subscribe, to comment, to like, to share. And we need to remind you that Physical Sciences Silver Bullet is a science channel specializing in physical sciences grade 12, 11, and 10, and natural sciences grade 8 and 9. We advise you to make use of our playlist. Just click on the playlist so that you can access the material which belongs to your level easily. For grade 8 and 9, just look for Natural Sciences Grade 8 or Natural Sciences Grade 9. For Grade 11 and 10, just look for Physical Sciences Grade 11 and Physical Sciences Grade 10. As for Grade 12, each chapter is presented independently. So just click on the chapter of your choice and you'll have all the material which belongs to you. With that, I'd like to say thank you. Stay blessed. See you next time. Bye-bye.